Alright, welcome everyone to our lesson today on perfect squares, perfect cubes, and their roots. So our goals for today is to understand what a perfect square and a perfect cube is, and to figure out the square or the cube root of a number. Right, so just going over some definitions first. A perfect square is a whole number that can be represented as an area of a square where its whole number is side length. And the square root is the side length of that square. So to be honest, that sounds like absolute gibberish. So here's an example. Let's take a square right here, and let's say its side length is 4. Right? So because a square side lengths are all the same, the area of a square is just 4 times 4, or the side length times itself. Right? So 4 times 4 gets us 16. Right? So in this case, 16 is a perfect square. And the 4 is just the square root of 16. Right? So square root of 16. Right? So you can think of it as any numbers that can be squared. So for example, we have 2 squared is 4. So 4 is a perfect square. We have, let's say, 5 squared. That gets us 25. So 25 is a perfect square. Let's go with a big number. Let's say 11. Right? So 11 squared is 121, which means 121 is also a perfect square. Right? So those are essentially the numbers that is a result of a number being squared. So the same logic applies to a perfect cube and a cube root. Right? So I pretty much just copy and paste the definition, but the only difference is that instead of a square and an area, right, we have a cube here. Right? So again, instead of area, and we're working with volume now. So for example, let's draw another diagram or a little shape here. We have a cube. So let's say instead of using 4, let's use 4 again. Right? A cube with the side length of 4. To find its volume, we have 4 times 4 times 4. That gets us 64, which means that 64 is a perfect cube. Right here, that's a perfect cube. And the 4 here that got us the 64 is considered a cube root. Right? So just like the squares, cubes are just results of numbers that are to the power of 3. So 2 cubed is 8, which makes it a perfect cube. 5 cubed is 125, right? Making it a perfect cube as well. And the last definition is prime factorization. We covered that with our last lesson in 3.1. But as a reminder, it is the factors of a number that are all prime. With that being said, let's go over some examples right away. Right, so our first question here is to find the square root of 1,296. So in other words, we have a square right here with an area of 1,296, let's say meters squared. We just have to find the side length of this set square. Right, so we are saying what number times what number equals to 1,296. And the quote-unquote what number here should be the same number. Right, so what number multiplied by itself is 1,296, or I guess essentially what we're saying is what number squared, or to the power of 2, is 1,296. So the way we go about it is to do prime factorization. Right, so 1,296. We'll do our good old factor tree here. That is divisible by 2. Get 600. Let's see, 4, 8. Also divisible by 2. This might take a while. 3, 2, 4. Still even. 2, 1, 6, 2. Still even. 2, 8, 1. Okay, almost there. 81 is just 9 times 9. 9 is just 3 squared. Alright, frankly, a pretty disgusting factor tree, but we can work with this. So, we have, let's see, how many do we have? 1, 2, 3, 4. We have 4 2s and 4 3s. So now what we do is to group all the numbers into 2 parts. Right? So in this case, we can put 2 2s and 2 3s into one group, and then the 2 2s and the 2 3s into another group. right? This means that we have two groups right here of 2 times 2 times 3 times 3. Right? 2 times 2 times 3 times 3, that is 4 times 9, or 36. Right? So once again, all we're doing is splitting the prime factors evenly into two halves that are equal to each other. And in this case, we got a 36 times a 36, which means that this square right here, the side length for this square is 36 by 36. Right? 36 times 36 is 1,296, which means that our answer, right, or the square root of 1,296 is 36. Right? And if we just want to check it, right here, let's get rid of those mysterious placeholder numbers here. All right, if we just do 36 times 36, or 36 squared, this is the number that we get. Right? So again, with prime factorization, all we are doing is figure out all the prime factors and then group them into two equal halves. All right, so now let's work with the cube roots here. So once again, all we are saying is, let's take this cube right here of a volume of 1,728 meters cubed. We have to find what's the side length of this said cube. Or we are saying what mysterious number to the power of 3 equals to 1,728. So once again, we'll do prime factorization. So 1,728. All right, just to speed things up a bit, we know this number is divisible by 4 because the last two digits of this number is 28. That is divisible by 4, which means that the whole number is divisible by 4. Right? Here's a fun trick for you. So, which we divide that by 4, we have 432. Okay, 4 broken down into 2 times 2. 432, once again, because it ends in 32, then which is divisible by 4, this whole number will be also divisible by 4. So that divided by 4 is 108. Okay, that breaks down to 2 and 2. 108 also divisible by 4, which broke down to 2 and 2. That divided by 4 is 27. Okay, now with 27, we know it's divisible, or factors are 3 and 9. 9 broken down to 3 and 3. Okay, here's an even more disgusting factor tree. 2, 2, 2, 2, 2, 2, 3, 3, 3. So now, to determine if it's a perfect cube, or to find its cube root, instead of splitting everything into two even groups, like we did with square root, we split everything into 3 even cubes, or 3 even groups. Right? This would probably be easier with a highlighter. So our first group will be, we'll take this 2, we'll take this 2, and a 3. That's our first group. Second group, we take this 2, we take this 2, and we take the 3. And the third group, we have the 2 2s and the 3. Right? So in all those cases, we have a 2, and a 3, which is 12. Right? Because we're able to split into 3 even groups, we know this number is a perfect cube, which means that the cube root, we read it like this, the cube root of 1,728, that equals to 12. Right, which also means 12 to the power of 3 is 1,728. Right, so that's pretty much it. That's how we find the square root and cube root of a number. We find all of its prime factors, try to divvy them up into equal groups of 2 or groups of 3. If in some scenarios, or actually in most of the scenarios, if we are not able to put those into those groups, then that number isn't a perfect square or a perfect cube. Alright, so that's about it. And with that being said, let's just hop right into some practice questions. So pause the video here, give it a shot, and we'll go over the answers in a bit. Alright, so hopefully you got some time to work on those questions. Alright, let's go over them. So, starting with 225. Right, 225, that is divisible by 5, because it ends in a 5, getting us 45 and 45. 45, that can be broken down into 5 and a 9. And with a 9, 3 and 3. And as we can see right here, those numbers can be grouped up evenly. So we have a 5 and a 3, and a 5 and a 3. All right, this means that the square root of 225 is just 3 times 5, which is 15. Meaning that this right here is a perfect square. Okay, 729. This right here is divisible by 9, because if we add up all the digits, 7 plus 2 times plus 9, we get 18. 18 is divisible by 9, so the whole number is divisible by 9. Okay, so that divided by 9 is 9 and 81. 9 can be broken down to 3 and 3. 81, 9 and 9, which is further broken down to 3 and 3 and 3 and 3. Okay, so here's the interesting part. We can group them in 2s or in 3s. Right? If we were to group them in 2s, we can have 3, 3, 3, and then 3, 3, 3s. All right, so we can group them in 2 parts. Or, so let's write it down first. All right, this, we can have the square root of 729 is just 3 times 3 times 3, which is 27. Meaning that this right here is a square root. However, what we can also do is we can actually also divide them up into 3 different groups. Right? So we can have 1, 3 here, 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 1, 3 here. So we can have 3 groups of 2 3s, which means that 729 to the cube root is just 3 times 3, giving us 9. Right? So for 729, it is both a perfect cube and a perfect square. Right? Pretty cool stuff. Okay, 1944. Alright, so because this number ends in 44, we know this whole thing is divisible by 4. Alright, so we got 4 here, that gets us 34, which is 2 remaining, getting us 6. Alright, next, 4 is can be broken down to 2 and 2. 486, that's divisible by 6, right there. The end was 8 and 1. 6, we got 2 and 3. 81, 9 and 9. Hope we have space here. 3, 3, 3, 3. Okay, here's an interesting one. Can this be broken into 2 or 3 even groups? Right, if we were to break it down into 2 even groups, one of the groups gets a 2, one of the groups gets a 2. However, we just have 1 2 left. Right, which means that this cannot be broken down into 2 even groups. Okay, let's try 3s. So we take a 2 here, a 3 here, okay? A 2 here, a 3 here, okay? 2 and a 3. We have 2 3s left over still. So all those prime factors together cannot be put into 3 different groups neither. Which means that this number right here, 1944, is neither. Right, it cannot be a perfect square or a perfect cube, unfortunately. Alright, lastly, 1444, divisible by 4 because it ends in 44. 3, 6, 1. Alright, 3, 6, 1. This is a really tricky one. If we keep going up the factors, we find out that 361 is divisible by 19, or it is 19 times 19. And the 4 is 2 times 2. And this one is pretty clear. We have 2 and 19 in one group, 2 and 19 in another group. Which means that 1444 can be square rooted because it can be divided into 2 different groups. Into 2 times 19, which is 38. Okay, so in conclusion, this number right here, this is a perfect square. This perfect square and a perfect cube, this is neither. And this is a perfect square. Okay, next, a cube has surface area of this number. What is its volume? So, the surface area of a cube is, well, let's write it down. Surface area, SA, is 6 times the area of one face. And we know the area is length squared, and we want its volume. And the volume is length cubed. Okay, so this is a multi-step process here. We are given the surface area. So with the surface area, we can find the area of one face. And now with the area of one face, we can find the length of that said face. And with the length of the said face, we can just cube the length to find the volume. Okay? So that's our thought process. So let's find the surface area. 6,534. This divided by 6 gets us 1,000. Got 0 here. We got 8, 48, 54, 1,089. So this is the area of one face. Okay? So now, in order to find the length of this set face, or the set cube, we just square root this number. So 1,089. Okay. We add the digits up, getting us, if we add all the digits up, we get 18. So 1 plus 0 plus 8 plus 9. 18 is divisible by 9, so this whole number is divisible by 9. That leaves us with 121. 121 is just 11 squared, so 120 is 11 times 11. 9 is 3 times 3. Luckily, right here, we can group them into 2. So the square root of 1,089 is 3 times 11, giving us 33. So 33 right here is the length of this set cube. And to find the volume of the set cube, we just have volume equals to length cubed, which is 33 cubed. Huge number. I will just use a calculator for this one, which will get us 35,937 meters cubed. Right, so this will be a pretty common word, or maybe not common, but this will be a word problem you can solve using what we learned today. And yeah, that's about it. So keep practicing and stay hydrated.